What causes a hurricane to rapidly intensify? This question often leaves meteorologists scratching their heads, and it's a question that came to the forefront with the unexpected intensification of Hurricane Otis in October 2023. The tale of Hurricane Otis started as a tropical storm off the Pacific coast of Mexico. On a sunny Tuesday, few would have guessed that the storm would escalate to a Category 5 hurricane within the next 24 hours. However, that's precisely what happened. Otis rapidly intensified, its winds accelerating by an astounding 180 kilometers per hour in just one day, a record-breaking phenomenon. The key factors driving this rapid intensification were a warm ocean and moist air, the perfect fuel for the convection forces at the storm's center. As Otis moved closer to the shore, it passed over a patch of water several degrees above the average temperature for late October, reaching a balmy 31 degrees Celsius. But it wasn't just warm waters that allowed Otis to intensify, it also needed freedom from cross-cutting winds, known as wind shear. The storm's inner anatomy also played a critical role. The symmetry of thunderstorms around the center of Otis kept the heat concentrated in the eye of the storm, causing dramatic drops in pressure and increasing wind speeds, leading to a formidable hurricane. Unfortunately, these internal conditions were hidden behind thick clouds from most satellites. Computer simulations fed with available data predicted that Otis would intensify gradually. It wasn't until aircraft flew into the storm and took direct measurements that forecasters realized their models were incorrect. This delay resulted in a disaster for the people of Acapulco, who were largely unprepared when Otis hit the Mexican coast. Acapulco was devastated. Massive landslides, power outages, and at least 24 deaths painted a picture of destruction. The aftermath of the hurricane saw tens of thousands left without power, communication lines severed, and the Acapulco International Airport rendered inaccessible. In the face of climate change, there is concern that rapidly intensifying hurricanes like Otis will become more frequent. While it's not clear whether such storms are truly becoming more common, recent evidence points to an upward trend, with warming oceans as the driving force. The story of Hurricane Otis serves as a stark reminder of the unpredictability of nature and the urgency of addressing climate change. It also underlines the need for improved weather forecasting models, capable of handling rapidly intensifying hurricanes. However, the reality is that nature can be hard to predict, and there is a limit to what any model or meteorologist can foresee. In conclusion, the rapid intensification of Hurricane Otis was driven by warm ocean temperatures, moist air, and the absence of wind shear. Unfortunately, forecasting models failed to predict this rapid intensification, resulting in widespread devastation in Acapulco. As global ocean temperatures continue to rise, there is a growing concern about the increasing frequency of rapidly intensifying hurricanes. Consequently, there is a pressing need to improve the predictive capabilities of weather forecasting systems. Yet it's important to remember that nature, in all its complexity, can sometimes be truly unpredictable.